and welcome to this demonstration of the GSG-8 GNSS simulator from Orolia. The GSG-8 is powered by our software-defined simulator, Skydel. I'm Lisa Perdue, Product Manager for Simulation at Orolia. I'm going to set up and run a basic GNSS simulation to show you the capabilities and ease of use of Skydel and the GSG-8. So we start by opening the Skydel software on the GSG-8. I'll go ahead and make a new configuration, and our output window is open for me. In this simulation, I'm going to use two of the RF outputs from a GSG-8. The GSG-8 can be configured with 1, 2, 3, or 4 RF outputs. So here we're going to use two. I'm going to use one for upper GNSS L-band signals and one for lower GNSS L-band signals. So if I press Edit, this is where I can select my signals. So I'm going to do GPS and Galileo. So I'll choose all the upper L-band signals for GPS and Galileo. We also, on RF output 2, want to select the lower L-band signals, and this is where we can choose our L2, L5 band signals for GPS and Galileo, and press OK. You'll notice that I didn't have to select how many of each satellite that I want. I don't have to assign them to channels. I don't have to worry about a channel count or which frequency is where. The software-defined architecture of the GSG-8 running Skydel allows us to just generate all in view. We can generate hundreds of signals from the GSG-8, so we don't have to worry about limiting any of the constellations or the satellites in them. If you want to generate a specific number of satellites, you can do that in some of the other menus. With that, by setting up the output signals, I'm really ready to go. I have a simulation status of ready, so I can press start and start generating the signals. But I do want to take a look at a couple other menu options in order to create our simulation. The first one is the start time. So I can choose a custom time, which we have a decent start time already in there that would work, or I can just choose to use my computer's time. So here is the actual date and time from my computer, and the other option is the GPS timing receiver time. If we want to synchronize accurately to the live time, we can do that using a GPS timing receiver. And next I want to look at the vehicle menu. So this is where we're going to define the trajectory for our simulation. So we can have fixed, which just means we're just going to stay in that same spot that you identify the entire simulation. We can have a circle. We can do track playback, which allows us to import NMEA or CSV files that you've previously either recorded or generated from another tool. We can do vehicle simulation, which is using OpenStreetMaps. We can generate a route from point A to point B, so that can be automatically done for you, so you don't have to define your own trajectory. We'll do it. The hardware in the loop mode is the mode that we have to set to allow us to accept the trajectory information in real time. And we have a Earth orbiting spacecraft trajectory tool to allow us to generate orbits for vehicles that may be in space. So you have spacecraft in low Earth orbit, medium Earth orbit, geostationary orbits, and highly elliptical orbits. Any type of orbit in space, we can generate that with the Earth orbiting spacecraft tool. So for this simulation, I'm just going to use a circle. So once I select that, I can press edit and change the parameters. So we have how big is the circle? I'm going to make it a little bit bigger. And then we have the speed, which I'm going to make a little bit faster. On the left, we have the center position of the circle. So we have a default position set, but you can choose your own. You can search for a location and use that. You can move the map and recenter it and move it to where you want. So there's a lot of ways to select where that center position is. So I'm going to choose that and press OK. In the vehicle settings, we also can add and change the antenna patterns. We can support gain and phase antenna patterns. So that's selectable there. And then we're all set. We're ready to go. We're ready to run the scenario. I'm going to connect a receiver real quick so that we can see the receiver feedback from the scenario right in the same interface that we're using to configure. So once I connect it, we can see the NMEA starting to come out of it. It's not filled in yet because we haven't started yet, so we'll go ahead and do that. I'm going to press start and start sending the RF over to my receiver. You saw it went from the status of ready to initializing to streaming RF. It only took about a second, so that's how fast the simulation can start. When I look down at the bottom at the Constellations tab, when we're running, this is where I can view the satellites that we're generating. Here, I can view them, independently of each other or all in the same sky plot. When I choose these, I can see which signals we're generating and what their relative power levels to each other are. And I can adjust that using these slider bars as well. So for each individual satellite, I can make some changes. For the entire set of satellites, I can make some relative changes as well. So I can do individual or all. It looks like that we have a position fixed from our receiver, so I'm going to go ahead and push the show receiver button so we can see what the receiver is reporting. So these are the satellites that the receiver sees. You can see they're the same as the satellites that we are generating. We can adjust these slider bars to raise and lower the power level, and you can see that happening in real time with the feedback from the receiver. On the next tab, we have the deviation. So this is the deviation from the truth data that's being output by the GNSS simulator. So that's the real, what we're simulating, and then what the receiver is seeing. So we can see in real time what that deviation is. So you have that automatic instant feedback. We can look at this GNSS spectrums on each radio. So what are we actually generating? What does that look like? What do those signals look like? And it's especially useful if you wanted to do some interference and jamming and you wanted to try and jam only certain parts of the spectrum. And then finally, we have the map. So we can see on the map the simulator and the receiver. So it looks like the receiver is very nicely following the simulator. And we have very small position errors. So I would call that a successful simulation. The receiver is doing what we expect it to do. The simulator is generating what we told it to. And I think that ends this demonstration. So thanks for sticking with me. And if you have any questions, you can always contact Orolia and we can do personalized demos, phone calls, whatever you need. If you need more information, just let us know. Thank you.
Find out more at Vicom's website.